Again, so that first one, so my calculator's out of the way. So that first one we subtracted, it stayed 1910 because of the margin of error. So 64,320 divided by 3.2 is 20,100. The units on that are nothing because inches and inches divide out. But we do still need to round to significant digits. When we multiply or divide, we preserve not precision, but accuracy. And accuracy is the number of significant digits. How many significant digits does this have? 1, 2, 3, 4. Is the 0 significant? No. So this has 4 significant digits. 3.2 has 2 significant digits. So we have to round our answer to 2 significant digits. So we start at the beginning. For significant digits to round, we start at the beginning of the number, 1, 2. So we have to round it right there. So it's going to round to 20,000. The problem is written like this. This only has 1 significant digit, the 2. So we have to make sure we do what? Indicate that 0 is significant. So that is indicated as having 2 significant digits. Anybody have that one right? Okay. Number 3. 12.31 feet plus 9.8 feet is 21.11 feet. We're adding or subtracting, which means we round to, we preserve precision, which means place value. This one is precise to the nearest what? 100th of a foot. This one has a precision of 1/10 of a foot, which means we're going to round our answer to 10th. 21.1. Anybody have that one? Nope, missed that one. And now 2.31 times 0.42. 0.9702. Inches times inches will be inches squared. Where do we need to round this? Yeah. This has 3 significant digits. This only has 2 significant digits. So we have to round to 2 significant digits. We're going to round right there. So 0.97 inches squared. Anybody have any major questions on that? Like I said, we will see it on a quiz today. Then we'll see it on a test at some point coming up in a couple weeks. There'll be 3 or 4 problems on it, and that'll be it. It's not something we're going to continue through in our calculations. It's mostly something for you guys to be aware of, so when you're reading any sort of a design calculation, or if there's an explanation for a calculation on a drawing, you can understand when they're rounding off. You at least know why they rounded off instead of having to guess why it's rounded off. Their rounding isn't just random. It does have to do with the measurements. Okay, so I'm going to pause here. I'm going to pass out the quiz. Any major questions on that quiz before I turn you loose on it overnight?
Yeah, absolutely.
What do you have?
Are we doing significant figures and everything?
Only on the ones that it asks for. So like the last, starting in the last 2 on the bottom of the front page, and then the back page deals with significant figures.
Okay.
Yep. Anything else?
What does it mean in the last question it says match?
Which number is most precise and which of those 2 numbers is most accurate? They might be the same. Might be the same number. Just take a line, draw a line from the most precise over to the one that's most precise, most accurate. Draw the one over the line over to the one that's most accurate. Like I said, it may point to the same number. Any other questions? Okay, so today we're going to start talking about measurement. And we're going to start mostly length measurement for right now. Now we've mentioned before that measurement came from a need to communicate. You know, if you were in the same room with me and we're building something, we're trying to build the same thing. If we want to build something the same size, and we're in the same room, I can just hold it up and you can look at it, or you can come over and set yours next to it and mark it off, and we've made them the same size. But if you're down the hallway or across town, we need some way to communicate what size is. Maybe, okay, so what we're building is this piece of paper, and you want to copy the size of this paper. I could take my pen and go, it's 1, 2, 2.5 pens long, which is great until it gets to you, and maybe your pen looks like this. So you've got 1, 2, well, your 2.5 pens is much longer than this, isn't it? So when I used that unit of measurement, I made two assumptions. One, that you had a pen, and two, that your pen was roughly the same size as mine. If the two pens are like this, that's not going to work because this one's much bigger than this one. So they're not going to be the same. So what they did was they chose things that, one, pretty much everybody had at least one of, and two, was pretty close to the same size from one person to another. And for the most part, it turned out to be parts of the body. For example, when we're talking about our customary units or standard units. Now, this used to be called the English standard or British standard units. Stop calling it that because it's been over 20 years now since England switched to the metric system. Actually, it's been close to 30 years now since they switched over. The United States is now officially the only industrialized country in the world that does not use the metric system. Of course, that gets into the whole debate. Are we going to switch over? The answer is yes, but the question is when, really. To be honest, the United States, rather than as a country saying we're going to switch, the government has left it to individual agencies to make the switch. Like right now in the United States, you cannot buy or sell liquor, gunpowder, or tobacco in standard units. It has to be sold in metric units. Like that's why you can't buy a fifth of a gallon, a fifth of whiskey anymore. It's a 0.75 liter bottle. Because the ATF, Alcohol, Tobacco, and Firearms, has gone metric. So anything regulated by them is metric. I believe probably the next agency to change over is probably going to be the Food and Drug Administration, FDA. You look at all your food is already dual labeled. You know, and your bottle of soda is 20 ounces or point whatever liters or so many milliliters is written on there. This is, what's that? 591 milliliters. There you go. So I mean, it's already got both units on. All your nutritional information is already in grams and milligrams instead of, you know, drams and minims and grains and all that stuff. So that switch is already kind of slowly in process. The two big things that are holding it up, one is driving. If I went out here on Highway SS and took down the sign that said speed limit 55 mph and put up a sign that said speed limit 88 kph, which is the same speed, but I know a lot of people probably get home a little faster tonight because they wouldn't catch the kph. So what's most likely going to happen there is kind of like with your nutritional information, you'll start seeing dual labels. In fact, if you go to larger cities, Wisconsin's a little bit behind. I think I only know of like one sign on 94 that's dual labeled with both miles and kilometers. But you're going to start seeing things labeled with both miles and kilometers. And actually, somebody told me here just a couple of weeks ago that the United States might be getting rid of all those signs that say, you know, Milwaukee 178 miles or whatever, because of the prevalence of GPS systems now, that you don't need to have a sign to tell you how far it is. Your phone tells you how far it is. So they're gonna stop maintaining those signs. They're still gonna have, you know, the turnoff saying, you know, Toma next exit or whatever, so you got a warning. But yeah, a lot of those might disappear. But you're gonna have to see dual labels, especially speed limits are gonna be dual labeled for a while before they make the switch.
I haven't seen any.
There's only one that I know of.
What about the cities? I haven't seen any.
I haven't seen any. I haven't driven over there now for a couple of years, but yeah, I mean, you go to like California. I know Florida. I've seen it.
Yeah, different languages on them.
Well, yeah. But that's a big hold. The other big holdup is what generation is in charge. You know, the CEOs of our major corporations. Not too many CEOs that are under 60 years of age. I mean, there's a couple in their 50s, but not many. Most of them 60 to 70 years of age are your CEOs of your major corporations. You go back to when they were in school, they didn't teach the metric system in school yet. They started teaching the metric system late 70s, early 80s. Depending on where you're at, sometimes it might have been into the early to mid 80s. So that age group did not learn the metric system. They're not comfortable with it. So literally, it's going to take that group to transition out of power into retirement, and the younger generation that's seen it to come in before there's much of a chance. Many major a couple major corporations that do international business, like IBM. IBM has switched over. Everything they do is done in metric units now. And they made their estimate. I can't remember what it was, but it was going to be like $12 or $15 million. They figured it was going to save them to do everything in metric units. Otherwise, whenever they designed something, they had to design it in standard units, but they had to convert it to metric units because some of their parts are made overseas. So they'd have to convert all their measurements and send it overseas. And those conversions were never perfect. So the parts they got back from overseas sometimes had a higher rate of reject because they didn't quite fit because of the round off and the conversions. So by switching over to completely metric, they figured they saved a lot of rejects, a lot of waste, and the money involved in doing all the conversions and stuff. They said it was like $12 or $15 million in the first quarter that they did that. So it is going to happen. It's just a matter of when. The United States seems to be a little bit more resistant to the change than I thought they were going to be. When I was in middle school, and I'm not going to date myself here now, but like 30 years ago, we were told within 10 years the United States is going to be completely switched over to the metric system. Now, I'm pretty sure that down the road here somewhere in a middle school, they're probably telling them the same thing. Within 10 years, we're going to be switched over. It just, for some reason, hasn't happened like we thought. So anyway, standard units, again, still looking at length. The inch is our smallest unit of length that we use in the standard measurement. Anybody know where the inch came from? Your thumb. It is the distance from the end of your thumb to the point of that first knuckle. So if I wanted to measure my piece of paper here, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. My thumb's obviously slightly larger than an inch because it's supposed to be 11 inches, right? I maybe moved it a little far too, but that is where the inch came from. Now you got to remember, most people's thumbs are slightly more than an inch right now if you were to measure them. But you got to remember back at the time when this was developing, the average height of a man was like 5'4". A man who was like 5'6" or 5'7" was a huge guy. You would have been average back then? So I mean, obviously, if they were shorter, their fingers were shorter too. So that's where that came from. You also notice the motion, by the way, as I move the thumb, that kind of rocking motion. That's where the inchworm kind of got its name, because it has that kind of same motion when it moves. What's that? They actually had their own version of measurement that we're not going to get into. Bigger than an inch, what's the next unit? The foot. No, actually the foot was a foot. It was from the back of your heel to the tip of your big toe. How many inches are in a foot? 12. No. What's that? Oh, 5'4". Well, here's the deal. These units did not go together. I mean, the original foot did not have 12 inches in it. In the 500s, King Edward declared that his thumb and his foot and everything else were going to be the official measuring units of the land. And so they came in and they took pieces of wood or whatever and they measured it to that size and they cut them. And that's what they used for measuring units, which was a very selfish act on King Edward's part, but it actually revolutionized measurement. We talked a couple classes ago about how they had those blocks and then eventually they took those blocks and they set them end to end and marked them on a stick to create a ruler. If King Edward had never done that, they had never created those little wooden blocks that were their measuring devices, rulers may have never developed. I mean, it was that innovation. I don't want to say innovation, like I said, it was just an ego trip on his part, but that's what really set us on the way of developing a measurement system. King Edward did not have 12 of his inches in his foot. But it was after King Edward had passed away that somebody said, hey, if you measure something in feet and I measure something in inches, it'd be really nice to be able to compare to see how they compare to each other. So that's when they adjusted the length of the foot and the inches to make them fit. Obviously, it was close to 12 because that was the closest thing to adjust it to was 12.
Who was King Edward?
King Edward?
Yeah, what?
He was just, at that time, it was England, Scotland. There was
Okay,
kind of,
yeah.
yep.
Is he in the movie Mel Gibson?
I don't know. I have no idea. Braveheart? Yeah, I'm not sure if he's the king that's in that one or not. But now, here's the deal. King Edward did that in his kingdom. But there were other rulers in other kingdoms at different times that did the same thing. So these standard units are anything but standard. So a different king would declare his thumb was the official inch of their kingdom. And so if you look at it, there are different units of these standard units. There's a different yard, a different foot, or whatever if you go from one country to another. That's why one of the reasons why the metric system was developed was to standardize everything, because it was a developed system. These systems were all, they kind of evolved. They came out of necessity, and then they kind of slapped them together to make a system. You know, inches, feet were never developed to be used together. They kind of forced them together to make a system because they were already in use. Now the foot was a pretty good unit of measurement. The only problem is, if I wanted to tell you how tall the wall is here, I could maybe get to about here if I did some serious stretching. Do you think I can measure all the way to the top of that wall with my foot? Not unless I chop it off at the ankle, can I? So the foot was only good for measuring things, lengths along the ground, because that's where your feet are. If I needed to measure something high up off the ground, it didn't work so well. So they had other units that we don't need anymore. That was one of the other innovations from King Edward, was once he did that, now they had this block of wood that was a foot. I could use that block of wood to measure up the wall. Didn't have to get my foot all the way up to the top of it. So units like the hand, which we don't use much anymore, which is the width across the hand at the base of the fingers here, between the palm and the fingers, which was about 4 inches. That was used for measuring heights because your hands could go up, you stack your hands up on top of each other. Now that is still used for livestock, sheep, horses, cows, just because it was a tradition. So it's still there, but it's really, because we have measuring devices now instead of having to use our body, it's kind of faded. Another one that was common, because it was slightly off the ground for construction, somebody asked about this one a few days ago, the cubit. Cubit is from the tip of your middle finger to the point of your elbow. This was used in construction. Now mine is a little bit longer than that, but back then, again, smaller people, the average man was about 16 inches from the tip of it actually wasn't the middle finger, it was the tip of your longest finger, whichever it was, to the point of the elbow. It was about 16 inches. Now, can you think of anything in construction that's about 16 inches? Pretty much everything. Stud spacing, joist spacing, rafter spacing, and the older style rafters. I mean, that was your spacing. So your craftsmen, that's all they did, is they laid their arm out, and that's how they spaced everything, was with their arm. We don't use those anymore. So we're going to step up to the next one we use is the yard. A yard is how many feet? 3 feet. 3 feet. A yard was a tailor's unit for measuring fabric. It was from the end of your outstretched arm to their either the tip of their nose or the center of their chest, depending on which kingdom you were in, what area you're in. Same distance, right? Center of your chest and the tip of your nose are probably pretty much the same spot. That was a yard. King Edward did the same thing with that. His yard's the official yard of the land. And they adjusted it years later to make it fit 3 feet. Now there is a unit bigger than a yard that we're going to talk about because it does come up often enough. That's a rod. A rod is 5.5 or 5.5 yards, or 16.5 or 16.5 feet. A rod was originally a shepherd's tool. The shepherd had the rod, and then they had the staff. The staff was like your little Bo Peep type hook. The rod was a defensive weapon. The staff, the hook, was to hook a sheep around the neck so you could detain them, so you could shear their wool or tend to a wound or anything else you needed to. the rod was a defensive weapon, literally fighting off wild animals with a big stick. So you look at 16.5 feet seems big, but if you're fighting off a wolf or something with nothing but a stick, you do want a little distance. And all it was just a sapling tree. They'd cut it down and debranch it, and that's what they used. How did it end up being used for measurement? Well, let's say that I have some sheep and Josh has some sheep, and we let them off down into the pasture, and they go down the same valley to graze. At the end of the day, I say, well, I had 12 sheep, and Josh says, well, I had 15 sheep, and there's 19 sheep down in the valley. We're probably both lying about how many sheep we had. And so there were a lot of fights about that. With cattle, how did they settle these disputes? Branding them, yes. This didn't work with sheep for a couple of reasons. One is the wool grew out too thick and it would cover up the brand. Two, wool is kind of flammable. So probably not the greatest idea. The skin of a sheep is not as tough as the skin of a cow either. Horses and cows, they branded. Sheep, you just couldn't see it. And they, ear tags and stuff like that were not readily available at that time. So sheep herding was actually the origin of land ownership, dividing up large fields of pasture land. I mean, house ownership was common, but actual grazing land ownership was not. Everything was free range up until that point. So what we would do is we'd pick out a rock and say, okay, I'm going to pasture my sheep over here, you're going to pasture your sheep over here. But arguments would come up, well, your pasture is bigger than mine or whatever. So what we'd do is I'd take my rod, we'd have a landmark like that big rock, I'd take my rod and lay it down. Josh would take his rod, put it end to end, and we go 1, 2, and then we just keep flip-flopping them and counting to measure out. Okay, my plot of land is 40 rods by 120 rods, yours is 40 by 120, we've got the same size. To this day, if you look at a legal description of a plot of land, it'll say, 3.5 rods from this marker, north of this marker, and 87 rods east of this marker. Land surveying is still done in rods. Bigger than a rod, of course, we have things like furlongs and stuff like that. But we're going to jump up to the mile. 1 mile, 5,280 feet is the most common one. 1,760 yards is the next most common one. 320 rods is in there too, but we're not going to worry. I'm not going to make you memorize that one. But anyway, the mile, there's a lot of different rumors about where the mile came from. One of them was that it was the distance that King Edward could see from his throne out across the valley of his land next to his castle. The most credible explanation I can find for the mile is actually from the Greek and Roman military. The Greek prefix milli stands for 1,000. Now, if you look at your taxes, there'll be a mill rate listed on your taxes. The mill rate is how much taxes you pay for $1,000 of value. Like a 22 mill rate means for every $1,000 of value, you pay $22 in taxes. So a $100,000 house, you pay $2,200 on it for taxes. So the mile meant 1,000, and it was the distance a Greek or a Roman soldier could march in formation 1,000 paces. So a pace was starting on the left foot, going to the right and back to the left. So that was one pace. So 1,000 of those was a mile. And that makes sense. If you start on your left foot, go to your right and back to the left, that's about 5.28 feet. Especially when you're a little shorter. Taller guys, it'd be closer to 6 feet. So that makes sense. So those are our standard units. If we wanted to look at metric units of length, in the metric length system, there's only one unit of length, and that is the meter. By the way, we're starting to spell it this way a little bit, M-E-T-R-E, the European spelling of meter. It's starting to catch on. Why? Because we're being silly. So 1 meter, abbreviation is M. If we need to measure something smaller, we have the prefix deci. So a decimeter, abbreviated DM, is 1/10 of a meter. Centi means 1/100th. abbreviated cm, so a centimeter is 1/100th of a meter. Milli is 1/1000th. So a millimeter is abbreviated mm, that's 1,000th of a meter. Now here you can see we go every 10, 1/10th, 1/100th, 1/1000th. We don't go every 10 after that. We skip and we only go every 1,000. So we would skip down from milli down to micro, which is 1/1,000,000th. Now since little m has already been used to abbreviate milli, we use the Greek letter mu for micrometer. That looks like this. I'll write it a little bit bigger. Looks like a U with a long tail on it. Now, in the medical fields, micrograms and micrometers is used a lot for medical assessments and prescription drugs and stuff. They have to key everything into a computer. Since there is no mu key on your computer keyboard, they abbreviated MCM for micrometer. And then you keep going. A billionth would be a nanometer, which is starting to become something that they're talking about in machining. Manufacturing, they talk about nanotechnology. It's faded a little bit. 10 years ago, you heard a lot more about it than you do now. But it is something we're moving into. It's just basically building things that are really, really small, is all it's talking about. Going the other way, if you want something bigger than a meter, you have deca. Actually, no K in deca. A decameter is 10 meters. Since dm is deci, they use dam or dkm for decameter. Dam is the most popular one. Next is hecto. Hecto means 100. So hm is a hectometer, that's 100 meters. Kilo is 1,000. So little km is a kilometer or 1,000 meters. Now again, we don't go up by tens anymore. They're going to skip up to million. 1 million is mega. So a megameter is 1,000,000 meters. Now notice I put a capital M on mega because the abbreviation for mega is a capital M. So it's a capital M, little m is megameter. One of the things we'll need to do is convert between units. In the metric system, it's going to be really simple. Let's look first at our standard measuring system. We talked about, when we did fractions, we talked about unity fractions and how you can multiply by 1 and it doesn't change the value, it just changes the appearance. So like we had a fraction like 3/4 and we might have multiplied by 3 on top and bottom. Well, 3 over 3 is 1, that's a unity fraction. We get 9/12. Changes the appearance but does not change the value. Well, we could do the same thing with a length measurement, 4 feet. If I want to change that into inches, now most of you would say, well, just multiply by 12, right? But what if you didn't know that? Well, you'd put that over 1, and we're going to use a unity fraction, a conversion factor, unity fraction. What's going to go on bottom here is feet, so that the feet will cross cancel out, and on top is going to be inches. Now we know that 1 foot equals 12 inches. This here is a unity fraction. It equals 1. You might look at it and say, well, it doesn't look like it equals 1. But 12 inches and 1 foot are the same length. They're just different ways of expressing it. So that does equal 1. So like we said, the feet now cross cancel out. 4 times 12 inches is 48 inches. And on bottom, 1 times 1 is 1. So 48 inches over 1 are just 48 inches. Like I said, most of you could have looked at 4 feet and said, hey, it's just times 12, it's 48 inches. But what if I give you something like 99 rods? Or actually, no, let's do 99 feet. And I want to convert it into rods. So we'll put it over 1. Feet are going to go on bottom, so they cross cancel out. Rods will go on top. Relationship between rods and feet, 1 rod is 16.5 feet. So the feet cross cancel out. 99 times 1 rod is 99 rods. 1 times 16.5 is 16.5. We divide that out. 99 divided by 16.5 is 6. So 99 feet is 6 rods. Same thing applies if I want to convert from metric to standard. If I have 5 inches and I want to convert that into centimeters, Well, I can look up and I can find a conversion that says 1 inch is 2.54 centimeters. Once I have that equivalency, now I can make my conversion. I'm going to make my 5 inches over 1. I'm going to multiply now by what's going to go on bottom. Has to cancel out the inches, right? So inches go on bottom. I'm converting 2 centimeters. So 1 inch is 2.54 centimeters. So you see here the inches will cross cancel out. On bottom it's just 1 times 1 is 1. On top it's 5 times 2.54, which is 12.70 centimeters. So 5 inches is 12.70 centimeters. If this wasn't 1 on bottom, you'd have to divide it out like I did with the rods up here. We'll look at those conversions more coming up in tomorrow's class as well. So anyway, in the metric system, to convert within the metric system, we can see that each place on this chart is either multiplying or dividing by 10. So when you multiply or divide by 10, it just moves the decimal 1 spot, doesn't it? So if I have something like 2.4 meters and I need to change it into centimeters, on my chart, from meters to centimeters is 2 spots to the right. My decimal point has to move 2 spots to the right. It's 240 centimeters. Or I might have 430 millimeters and I want to change it into meters. On my chart, millimeters to meters is 1, 2, 3 spots to the left. Here's my decimal point. I'm going to go 1, 2, 3 spots to the left. It's 0.43 meters. Make sense? I got a little long-winded today, so we'll talk more about this stuff tomorrow in your little book. Unit. Actually, it's not in your little book. I actually have to give you a packet. In the packet I'm going to give you, it's going to be Unit 19 in that packet. So like I said, Unit 19 in that packet. Hold on to the packet because we're going to do the rest of it eventually. With that, I'll give you guys the last couple minutes here to get started.